Hi guys, welcome back to Shabest online tutorial. In today's tutorial, we're going to learn how to find the mean and the variance of a gamma distribution. And the gamma distribution, x is distributed gamma into parameter alpha, theta. And f of x, which is the function, is given as what? Theta raised to the power of alpha all over what? Gamma of alpha multiplied by what? X to the power of alpha minus 1, then exponential raised to the power of minus theta x. So an x is greater than 0. That means the limit x is reduced from 0 to positive infinity. So to look for the mean, first of all, we're going to look for the mean. And the mean is the same as what? Expected value of x, which is the same as what? Integral from negative infinity to positive infinity, x multiplied by f of x dx. And this f of x is the function of gamma distribution. So we're going to have what? Expected value of x, which is equal to integral. X is reduced from 0 to positive infinity. Then x multiplied by the function, which is what? Theta raised to the power of alpha all over gamma of alpha multiplied by what? X to the power of alpha minus 1 e raised to the power of minus theta x, then dx. So now we're going to integrate this with respect to x. So expected value of x now will be equal to what? First thing we're going to do, we're going to take this out. We're going to have what? Theta raised to the power of alpha all over what? Gamma of alpha, then integral from 0 to positive infinity. When this is out already, then we have x and x. The bases are the same because this x is raised to the power of 1. It's still the same. So recall multiplication law of indices. Since the bases are the same, we write one of the base, then we add the power. 1 plus alpha minus 1. This minus 1 and this plus 1 is going to cancel. We are left with what? Alpha. Then exponential minus theta x and dx. Now the next thing, we are going to let u to be equal to what? Theta x. And x is equal to, we make x the subject of the formula by dividing through by theta. So we're going to have u over theta. Then the x, we differentiate x. The x now will equal to du over theta. So now the next thing we're going to do is to replace it back to our function. We're going to have what? Expected value of x, which is equal to theta raised to the power of alpha all over gamma of alpha integral from 0 to positive infinity. In place of x is u over theta. So u raised to the power of alpha over theta raised to the power of alpha. Then exponential minus, in place of theta x is the same as u. Then du is this, the x is the same as du over theta. We are going to have du over theta. Now this theta raised to the power of alpha is going to cancel out this theta raised to the power of alpha. So we're going to take this theta out. So if this cancel, this place we are left with what? 1. So 1 now over, if this, we take 1 over theta out, is going to be what? Theta over what? Gamma of alpha, then open integral from 0 to positive infinity. So this place will remain only u to power alpha e raised to the power of minus u, then du. And the whole of this from this integral down to du is the same as what? Is the same as gamma of alpha plus 1. And gamma of alpha plus 1 is the same as what? Gamma plus 1 minus 1 factorial. So this is the same as, this is going to cancel, the same as what? Alpha factorial. And alpha factorial is the same as what? Alpha factorial is the same as what? Alpha into alpha minus 1 factorial, which is the same as what? Alpha multiplied by gamma of alpha. So in place of this is going to be what? Alpha multiplied by gamma of alpha. So in place of this, from here to this place, we're going to replace alpha multiplied by gamma of alpha. So this is going to be what? 1 all over expected value of x now be equal to 1 all over what? Theta, then gamma of alpha multiplied by what? Alpha, then gamma of alpha. So that this is going to cancel out this. Then expected value of x now will be equal to 1 multiplied by alpha is alpha. Then we are left with only theta here. So this is the mean of a gamma distribution. Now the next thing is to look for the variance, and the variance of x now will be equal to what? Expected value of x squared minus expected value of x all square. And we are finding expected value of x to be what? Alpha over theta. So what we are going to find now is expected value of x squared. And expected value of x squared is the same as what? Integral from negative infinity to positive infinity x squared, then f of x dx. So this f of x here meaning our function, and x squared, we're going to multiply x squared by our function, then we integrate with respect to x. Expected value of x squared now will be equal to integral from what? 0 to positive infinity. Remember, x is ranging from 0 to positive infinity. Then x squared, then f of x, which is our function, is the same as what? Theta raised to the power of alpha all over what? Gamma of alpha multiplied by what? X to the power of alpha minus 1, then e raised to the power of minus theta x, then the x. The value of x squared now will be equal to, so we are going to take this constant out, theta raised to the power of alpha all over gamma of alpha. So we have theta raised to the power of alpha divided by gamma of alpha, integral from 0 to positive infinity, x squared and x. When they multiply, we write one of the base according to multiplication property of indices, then we add the power. 2 minus 1 is the same as plus 1. So the power now will remain alpha plus 1. Then exponential raised to the power of minus theta x, then the x. Now we let u to be equal to this power, theta x. Then x now will be equal to what? When we make x the subject of the formula, is going to be what? U over theta. Then we differentiate this. It's going to be what? The x, which is equal to the u all over theta. Now I'm going to replace this back to the function. We're going to have what? Expected value of x squared, which is equal to what? Theta raised to the power of alpha all over what? Gamma of alpha, integral from 0 to positive infinity. In place of x now is what? U to the power of alpha plus 1 all over what? Theta raised to the power of alpha plus 1. Then exponential raised to the power of minus theta x, and theta x is u. So minus u, and dx is the same as what? Du all over theta. So we're going to have expected value of x squared, which is equal to what? This is going to cancel one of these, because this is the same as what? Theta raised to the power of alpha multiplied by what? Theta raised to the power of 1. So this is the same. So that one of these is going to cancel this. We're going to have what? 1 all over. We have 1 theta left here. Then that theta multiplied by this theta is going to be what? Theta square. Then we take that theta square out, then multiply by what? The gamma, initial gamma of alpha, then integral from 0 to positive infinity. So we are left with what? U to the power of alpha plus 1, u to the power of alpha plus 1, then exponential raised to the power of minus u, then du, because this theta is out already. And the whole of this is the same as what? Gamma of what? Alpha plus 2. And gamma of alpha plus 2 is, this is the same as what? Alpha plus 2 minus 1 factorial. And alpha plus 2 minus 1 factorial is the same as what? Alpha plus 1 factorial. Where alpha plus 1 factorial, if you simplify this, we are going to have what? Alpha plus 1 multiplied by what? Alpha multiplied by alpha minus 1 factorial, which is the same as alpha into alpha plus 1, then multiplied by what? Gamma of alpha. So therefore, the whole of this is equivalent to this. We're going to replace this. We're going to replace alpha into alpha plus 1, then gamma of alpha in place of this. Then we are going to have, then expected value of x squared now will be equal to, when we replace this, it's going to be alpha into alpha plus 1, then gamma of alpha all over theta square multiplied by what? Gamma of alpha. So that this gamma of alpha is going to cancel out this gamma of alpha. So expected value of x squared now will be equal to what? Alpha into alpha plus 1 all over what? Theta square. So therefore, variance of x now will be equal to what? Expected value of x square minus expected value of x all square. And expected value of x square is this, which is what? Alpha into alpha plus 1 all over what? Theta square, minus expected value of x all square. And expected value of x, we find it to be what? Alpha over theta. But remember, it's all square, so we're going to square it to be what? Alpha square over theta square. Then variance of x now will be equal to what? The LCM is theta square. Then since the LCM are the same, then we subtract the numerator. We're going to first expand this. Alpha multiplied by alpha is alpha square, then plus alpha multiplied by 1 is alpha, and minus alpha square. So that this alpha square is going to cancel out this alpha square because this is positive alpha and this is negative alpha. So therefore, variance of x of gamma distribution, it will be what? Alpha all over theta square. So this is the variance of gamma distribution, or is what? Alpha over theta square, and the mean is alpha over theta. So this is how to find the mean and the variance of a gamma distribution. Thank you for watching, and please follow and subscribe for more video like this.